Addition of oxygen, removal of
Addition of oxygen.
Addition of oxygen or the removal of hydrogen. What is the meaning of reduction?
addition of hydrogen, removal of oxygen.
Addition of hydrogen.
Removal of oxygen and addition of hydrogen.
Very good. So only these are the two important rules for the oxidation and the reduction. That is only in terms of oxidation and reduction. Okay, sorry, oxygen and hydrogen. Fine, but in terms of electrons also we have the oxidation and reduction. There is a oxidation reduction in electron concept. Okay. If you can't hear my voice in between, you just tell me.
You said so actually. Electronegative element is called adding of most electroelement negative is called oxidation, and adding of electropositive element is called reduction.
Okay, but actually we have some other rules are there. That is in the terms of electronegative and electropositive actually. Okay, so I'll teach in terms of electrons, removal of electrons, gaining of electrons, or losing of electrons and all. So next topic is oxidation and reduction in terms of electron transfer.
Okay, sir.
So first, oxidation means what? Loss of electrons. Oxidation means what?
Loss of electrons, sir.
Loss of electrons.
Electrons. Reduction means gaining of electrons. Okay. So again, I will teach you the oxidation number method. Loss of electron means what? Suppose if you take example like M, or I will take it here itself, like M gives rise to Mn plus N electrons. Understanding what I'm writing? M is the some metal. It is losing N electrons and will form the Mn plus cation. Are you understanding the terminology here?
So can
Yes,
you
sir.
repeat?
Electrons are losing.
Yes, sir.
If the electrons are there on the product side, that is a losing, right? Yes or no? M is in the solid state, is in the aqueous state. It is losing N electrons. Now the same thing, if you write for the reduction, what you will write? Same thing, if you write for the reduction, what you will write? Mn plus N electrons are gaining. Reactant side are gaining, right? To form M. Clear? Electrons are gaining. Is it clear? These two equation part.
So what is mean by M there, sir? Is that element?
Yeah, M is any element here.
Yes. Sir. So any positive element gives positive element plus it loses the electrons is called oxidation.
Yeah, if you take example here,
Yes.
zinc is there. If it loses the electron, it will form Zn plus 2. So losing 2 electron means 2 electrons are there, right? So what is happening here? Zn is moving from Zn to Zn plus 2 state, right? So it is a oxidation. Clear?
Yes.
Is it clear for everyone?
Yes, sir.
Next, chlorine is there. If it gains 1 electron, it will form Cl minus 1. What is this? Chlorine plus electron gaining. Gaining, it is forming Cl minus 1. Okay, so it is a reduction.
Reduction.
Understanding the difference?
Yes, sir.
So oxidation means loss of electrons. Reduction means gain of electrons. Any doubts? Any doubts in this?
No,
No,
sir.
sir.
Okay, now I'll ask you some basic questions here now. So, okay, we'll keep it as a note here. Suppose if the element is there in the Na state, it is moving to Na plus 1. Is it the oxidation or reduction?
Oxidation.
Oxidation. Is it clear for everyone?
Yes, sir.
Now, one more element is there, Fe plus 2. It is moving to Fe plus 3. Is it oxidation or reduction?
Oxidation.
Oxidation, sir.
How?
Oxidation.
Its electron is removed.
As we remove the electrons, the plus charge will goes on increasing, right?
Yes, sir.
Oh, yes, sir. Yes, sir.
Yes or no? Plus 2, we are removing one more electron. That means plus 1 proton already increasing. So it will become plus 3. So in simple words, sorry. In simple words, we can say like moving from lower number to higher number is oxidation, right? Can we say like that?
Yes, sir.
Yes, sir. Yes, sir.
Moving from lower number to the higher oxidation number is oxidation term. Is my statement clear for everyone?
Yes, sir.
I am getting response only from 1 or 2 candidates.
Yes, sir. Yes, sir.
Yes, sir.
So only I left some gap here. Moving from lower oxidation state to higher oxidation state. Just to understand, this is oxidation, okay? I'm writing in the shortcut. Higher oxidation number. Then what is the reduction? What is the meaning of reduction? Moving from higher oxidation number to lower oxidation number. Is it clear or any doubts?
Clear, sir.
Yes, no.
Everyone,
Yes.
fine. So that's all simple. Oxidation reduction. Just you find out which one element is undergoing losing the electrons, which element is gaining the electrons. Gaining the electrons on reduction, losing the electrons is the oxidation. Okay,
Okay, sir.
fine. Still you have any doubts, you can ask me. I will explain you here itself. So this is the page. It's very important. And this is very important in the higher standard actually. Now I will teach you the oxidation number rules. Actually, that is not in the syllabus of 10th standard at all. But I will teach you that method so that it will be easy for you to understand how to find out this higher number, lower number, oxidation number and all. Before the teaching, you tell me if any doubts are there in this, I will explain you.
No, sir.
No doubt, sir.
Yeah. So next we are going to learn the oxidation number rules. So how to find this oxidation number actually? Just wait a minute. First rule is if element is in the pure form, element is in pure form or in free state. Okay, then oxidation number of that element is 0. Oxidation number of that element is 0. What is the meaning of pure form or in the free state? Any examples? Suppose if we take sodium, it exists in the Na plus only, right? Na only, right?
Yes.
Yes.
Iron. These are the neutral elements. There is no charge on it. So Na, Fe, Au, Ag. Okay, these are the elements without any charge is there on that. So whenever the periodic table elements are there without any charge in the pure form, we'll take oxidation number is equal to, what is the oxidation number? 0.
0.
What is that 0? Where we will write that 0? This number is there, right? That is a 0, right? Understanding? Is it clear?
Yes, sir.
Now, fine. Pure form we finished. Now, suppose if you take some elements, they'll exist only in that state in the nature, like hydrogen. What is how it is exist in nature?
H2.
Explain.
H2. Next, if you take oxygen, how it will exist in the nature?
O2.
O2, sir.
Chlorine, bromine, iodine,
In the terms of
right?
the charges too.
So all this will exist in the nature in the form of H2, O2, Cl2, Br2, ozone, O3, and all, right? So these are the free state elements, right? They exist freely in the nature in the form of H2. They will exist, oxygen will exist freely in the nature in the form of O2. Understanding the difference between the pure form and the free state. Now, this elements also will have the oxidation number 0. Fine.
Sir, could you tell again the difference?
See, suppose if we take hydrogen, it cannot exist in the form of only single H, right?
Yes, sir.
It will exist in the form of either H2 only. If you take oxygen, can single oxygen exist freely?
No, sir.
No, sir.
Freely it will not exist, single oxygen. But O2 will exist freely in the nature, in the air. Same way, if you take chlorine gas, it cannot be a single Cl. It will exist in the nature in the form of Cl2 free state. So free state elements also will have the oxidation number 0. I hope you understand now.
Sir, could you name a few which is not free state and which is not in pure form?
Simple trick is, which are the element you see in the periodic table without any charge, that is a pure form. 118 elements are there, right? All
Yes,
the
sir.
elements without any charge, that is a pure form. If it exists without any charge on it, that is a 0. Clear?
Yes, sir. Okay.
Now, which are the element will exist only in the combined format, like H2, O2, Cl2, Br2, O3, and all. These are the elemental pure state, sorry, free state. So by doing some examples, you'll get to know all these things. Okay, don't worry.
Sir, can compounds be in free state or oxidation? In
Compound is in the
or
free
free?
state only, actually. I'll tell you the rules. So one by one we'll study,
Okay.
don't worry.
Yes, sir.
Second rule. Second one is the oxidation number of ion. The oxidation number of an ion is the same as charge. I hope you understand this. Example, suppose Cl minus 1 is there. Here Cl2 is the free state, but Cl minus 1 is not the free state, right? It is one ion. First, what is the meaning of ion?
So the charge of a particle
Atoms
element?
carry charge.
Yes, sir.
So it can be cation, it can be.
Anion.
What's the cation? Which is carrying positive charge, that is a
Positive.
cation. Which is carrying negative charge, that is a anion. Right? Now if you take Cl, Cl minus 1 is the ion. Then what is the oxidation number of this? What is the oxidation number? Oxidation number is same as the charge on the ion, right? So it is a -1. Okay, clear?
Yes, sir.
Fine. Now, if you take one more like a Mg plus 2, what is the oxidation number?
+2.
+2.
Plus 2. Clear now?
Yes,
Yes,
sir.
sir.
Yes, sir.
If you take Cr plus 3, oxidation number
+3.
+3.
plus 3. If you take only Mg, what is the oxidation number?
0.
Very good. Mg, there is no charge, right? So it is in the free state. It is a 0.
Yes. So which
Okay.
are in not free state, what will be calling them, sir?
You can state a pure form, simple, or elemental state, which is there in the
Yeah,
element
Mg
format.
is in pure form, no, sir?
Yeah, Mg is in the pure form, or you can say elemental state. Both are same.
Sir, I'm asking at which are not in pure form or free state, what will be calling them?
Ions.
Okay.
Ions are the compounds. Okay.
So Cl and Mg2 plus all these are compounds, sir.
No, ions. Whichever is
Okay.
carrying the charge, that is ion, right? So Cl minus 1 is ion, anion. Mg plus 2 is a cation. Cr plus 3
Yes,
is
sir.
a cation. Mg is the neutral atom, elemental format.
Okay, sir. Understood, sir.
Okay. But do you know one chart? Just wait a minute. I don't know whether I have given this chart for you or not. Periodic table. First group always will show only +1 state. Did I give the chart to you?
So I think no.
It's very important along with that valency chart.
Sir, can you send the valence chart again, sir?
Yeah, sure.
This you
Actually,
gave, sir.
yeah. So whether Kavya is there in the group? Sorry. Are you there in the class, Kavya? No. Shreyan? Shreyan?
Yes, I'm there.
Yeah, just you can check it the group in the previous media because it's
Okay.
actually deleted in my phone. And
Yeah.
forward the same thing in the again in the class group.
There, our classroom, huh?
Yeah, in the class 10th group, I sent 3 charts,
Sir,
right?
I cannot send, no, sir. I am not admin, right?
You just forward it to me.
Okay, sir. Okay, sir.
Okay. After
Okay,
this
sir.
class, you can forward it to me because that media is got deleted from my phone.
Sir, miss, this periodic table, what you have shared, I should share with you.
Yeah, sure.
Yeah, okay, sir. Okay.
And that one message is also there, right? Which I have sent to you, like a video 1, 2, 3, 4 links and all.
Yeah. Yes.
That also you can forward to me. I will forward that.
Class
Okay.
record.
Yeah, sir. Okay, sir.
Thank you. So this is the chart which is very important. First, because if you take first group elements, all will show +1 charge. Second group elements all will show +2 charge. Third group +3, fourth group +4, fifth group -3, sixth group -2, seventh group -1, like that. And noble gases will show 0. Understanding?
Yes, sir.
Yes, sir.
It is also compulsory. You have to remember the elements in the group wise. The same table we'll use in the periodic table in the chapter number 5. We have complete one chapter on the periodic table in the class 10th. So there also it will be useful for you if you learn now itself. Okay. Will you do that homework today? I think so. I have given already this homework in the starting of the class itself. Starting of the
Yes,
session
sir.
itself.
To learn valences, to write chemical compounds, you told to learn, sir.
Yeah, but I didn't ask you afterwards also. So, but next class I will ask you. Okay. laptop ki charger. Okay. So Paka, you have to remember read all these 8 groups: first, second, third, fourth, fifth, sixth, seventh, eighth. That is the third rule. First group elements na +1, second group elements na +2. Yeah, sorry. So first group elements will show +1, second group element will show +2. Like that and all, you have to remember in the group wise all the elements. That is the third rule for the oxidation number method. Next, fourth one. If you take hydrogen, can you hear me?
Yes, sir.
If you take hydrogen, it will show +1 with the non-metals and -1 with the metals. That means whenever the hydrogen is combining with the non-metals, it will show the valency of +1, and when it is combining with the metals, it will show the valency of -1. Understanding?
So can you explain it again, sir?
Like if you take examples, sodium hydride. Hello.
Yes, sir.
Yeah. Sodium
Yes, sir.
hydride. If you take sodium hydride, what it will show? Na will show always +1 only, right?
Yes, sir.
And sodium is a metal. So whenever the hydrogen combining with the metals, it will show the charge of -1.
Oh,
Clear?
yes, sir.
Now,
So can you give an example for non-metal?
yeah, HCl. Cl is what?
Liquid form, liquid state. Non-metal.
Non-metal. Now hydrogen will show charge of
+1, sir.
+1. Cl will show -1. Clear
Minus
now?
1. Yes, sir.
Is it clear for everyone?
Yes, sir.
Next. So hydrogen will show +1 with the non-metals, -1 with the metals. Rule number 5. If you take oxygen, it has a 3 states: -2, -1, -half. -2 in the oxide form, -1 in the peroxide, -half is the superoxide. Okay. Okay, then we'll take the example like monoxide CaO. Calcium belongs to which state? What is the oxidation number of calcium? Hello.
Yes.
Yes, sir.
Calcium oxidation number. Calcium is here, right?
Yes, sir.
What is the oxidation number?
+2.
+2. +2 means oxygen has to show
-2.
-2. Understanding?
Minus 2.
To make it
Yes.
neutral. Now, if the oxygen is in the -2 state, now what we can call it as?
Oxide.
Calcium oxide. So we'll call it as a oxide. First one finished. Second one. If you take like this, sorry, Na2O. Suppose sodium is belongs to which group?
Group 1.
Group 1. So it will show +1. Okay.
Yeah.
Then oxygen has to show
-2, sir, because 2 sodiums are there.
Minus 2.
2 sodiums are there. Okay, you can take as a -2, but here, okay, you can take like this. Now you tell me, what is the oxidation state of oxygen?
-1.
Minus
-1.
1.
Then what is the name of this?
Peroxide.
sodium peroxide. Clear?
Yes, sir.
Yes, sir.
Okay. The next one, KO2. So potassium is showing, potassium belongs to which group? Potassium belongs to which group?
Could you repeat?
Potassium belongs to which group?
Group 1, +1.
Group 1. So it is a +1. Okay, what about this? O2
Minus half.
minus half. Then what is the O2 format here?
Superoxide.
Potassium superoxide. I hope everything is clear now. When you use the oxide, when you use the peroxide, when you use the superoxide. Yeah.
So peroxide, once again, can you explain how we got -1 there?
Sodium is +1, so it will show 2 into +1
Minus.
+2. Or okay.
Yes.
Now oxygen is -2, but we have two oxygens are there. So 2 into -1 -2. So both will
Minus.
cancel out each other. You got 0, right?
Yes. Yes, sir.
If oxygen is the -1 state, then that is a peroxide.
Yes, sir. Got it.
Rule number 6. Always fluorine will show -1 because of most electronegative element. Okay, always fluorine will show -1 because of most electronegative element. Rule number 7. In a compound, sum of oxidation number is always equal to zero. In a compound, sum of oxidation number is always equal to 0. Clear?
Yes, sir.
Can you hear me or not?
Yes, sir. We can hear you.
Yes,
sir. So in a compound, sum of oxidation number is always equal to 0. So these are the 7 rules. What is the first rule? What is the first rule? If the element is in the pure form or in the elemental state, in the free state, the oxidation number is equal to 0. Next one, the oxidation number of an ion is same as the charge. Okay, the oxidation number of ion is same as the charge. Rule number 3, particular group always will show particular valency only, like group 1 will show always +1, group 2 always will show +2, group 3 always will show +3, 4 always will show +4, 5, 6, 7, 8 will show -3, -2, -1, 0. Rule number 4, hydrogen will show +1 with the non-metals and -1 with the metals. Rule number 5, oxygen will show 3 oxidation states: -2, -1, -half, -2 with the oxide, -1 with the peroxide, -half with the superoxide. Rule number 6, fluorine always will show -1. Okay, and in the compound, sum of oxidation number is equal to 0. That is the rule number 7. Fine. Any doubts in this?
no doubt, sir.
Okay, now we'll take one example here. KMnO4. Okay, so to take the KMnO4, KMnO4. If you want to find out for the Mn oxidation number, you are finding the Mn oxidation number. So this is the unknown value, right? So we'll take it as a X. Okay, now potassium belongs to which group? Potassium belongs to which group?
First group.
First group. That means it will show +1. Oxygen will show 4 oxygens are there. Each oxygen will how much?
-2.
-2. So 1 plus x plus 4 oxygens are there. 4 into -2. Overall equal to what? In a compound, the sum of oxidation number is equal to 0. So overall equal to what?
0.
0. That means 1 plus x minus 8 equal to 0. So x equal to +7 only, right? Yes or no? Understand how to find the oxidation number of understand?
Yes, sir.
Yes,
X equal
sir.
to +7. So in this way we will find out now. Clear?
Yes, sir.
Now if you take this one, H2Cr2O7. Cr we will find out oxidation number. We don't know how much it is. Okay. So if you don't know now, what will take? X. How many X are there? 2. Okay. Hydrogen what? What about the hydrogen?
+1.
Hydrogen is +1. Okay. What about the oxygen? -2 equal to 0. Fine. Hello. Hello.
Yes, sir.
Yes.
Can you hear? Can you understand what I solved here?
Yes, sir.
Yes, sir.
So 2x minus 13 equal to 0. So x equal to 13 by 2. Sorry. 13 only. H2Cr2O7. H is a, sorry, 2 we have to take here. So 2, 14, 12. 12 now. 12 by 2 equal to 6. That means x equal to +6. So oxygen, chromium will show oxygen state of +6. Okay. Clear?
Yes.
Yes, sir.
Yeah, fine. Next, we'll take one more. H3PO4. Yeah. H3PO4. Now tell me for phosphorus. Tell me for phosphorus. How we can find phosphorus?
Sir, is it 5 plus 5?
Very good. How much?
Plus 5.
So 3 phosphorus is x plus 3 minus 8 equal to 0. So x equal minus 5 equal to 0. X equal to plus 5. Good. Next, sulfur. Find out for sulfur.
2.
What is for sulfur?
Six, sir.
What is the answer?
6.
Sulfur is x plus
Yes, sir. 6.
2 plus x
-8.
minus 8 equal to 0. 6 minus 6 equal to 0. X equal to plus 6. Understand?
Yes, sir. Got it.
Yeah. Any doubts?
No. So this is itself, right?
Hear your voice.
So this is in 9th itself, right?
Oxidation number.
Yeah, first UT. Language of chemistry, it was there.
Okay. Maybe you're in the ICSE.
Yes, sir.
They're in the ICSE, but actually it is not there in the CBSE board.
Okay.
Okay. So clear, right? Any doubts in this?
No doubts, sir.
Yeah, fine. Okay. So remaining things I'll explain in the next class. Is it fine?
Yes,
Yes,
sir.
sir.
Yeah. So we'll end the class here itself. It's not audible to me proper also. I'll cover this 15 minutes composition class in next class. I will add for that. Okay.